So I'm Stanley Younglive. I'm going to give you a short introduction to the RTA-1 Real-Time Analyzer. It has two parts. This is a Windows computer up here, which is running the basic stamp editor, and we get a debug terminal there, and the device, the RTA, is reporting its output to the debug terminal up here. On this terminal, we see that the GPS unit has already grabbed our position and by satellite and our time, and we're indoors here, and we've got 4 satellites, so that's pretty good. This is the GPS. This is the basic stamp. This board is called a BOE, a Board of Education, which is made by Parallax. It connects via this USB cable up to the PC. The rest of this is what I built. It has a few parts here. This is a counter, a 16-bit counter, and there are LEDs across here in this whole system, basically for check purposes as I was developing. A lot of the wiring is unfortunately dedicated to LEDs and resistors and drivers. They can be pulled out in production, but for development they were needed. These relays, these yellow relays, are blocks. I'm going to stop. It's cycling right now. It's counting up through 16, and it's checking the difference between the sensor and the memory, the mirror memory of the last reading. So far it's found 9 differences, and that's the end of the cycle. So this cycle is 9 changes at these addresses. 1024 and 0 are very volatile. The rest yield interesting info. You can go back and see that prior to this, on the cycle before this, when nobody was near the machine, it just measured 1 change. When I come up to the machine and start talking about it, it measures 9. Now that's only 1 test. It actually takes longer than that to accommodate, but that's the kind of thing we're looking for. Alright, so before I was interrupted by that cycling, I was going to tell you that these relays closed in order to allow us to read the sensor as a regular memory device. Do the comparison against the mirror memory. That is hardware compared over here via a 688 chip, and that signal goes back to the processor and tells whether there was a match between those addresses or not. That have to be a match in the data at those addresses. Now we're looking just at bytes. It's an 8 byte by 8 byte comparison. So within an address, 1046, I can tell you that address changed out of 8,000. I can't tell you with this hardware which bit changed, and that would be a reason to improve that. In fact, if you wanted to improve it all the way, this is what you'd get. This is our next version of the sensor. It has relays for each pin of the sensor, and lots of pretty lights to impress people. So that's it. As it runs, it will generate the report on the debug. You can copy this and paste it onto a text file and print it out. The RTA was built as an answer to the question, how do we visualize data changes that we see in the EEPROMs? And one way to do it would be color, but I thought that was very arbitrary. So at this level, I just wanted to prove that the bits are changing. And of course, at the research level after this, we proved that it's not random. Now, here's my cell phone. Everybody knows it is on, actually. So cell phones generate a lot of electromagnetic activity. It's been here actually all along. I'm going to put it right on the sensor here. And while it's sensing, in a little while it's going to come around and tell us what it says. And there were 9 changes with no cell phone on the sensor. And my bet to you right now is that with the cell phone on the sensor, there will in fact be fewer than 9 changes. And that is going to prove that the sensor isn't picking up normal electromagnetic energy. Because if it were, I think everybody agrees that the cell phone should absolutely overwhelm any sort of subtle energy sensor. So we'll just wait just a little bit longer and see what happens. Here we go, we're beginning to count. There's the GPS. The relays have closed. It's counting. And it has finished counting. I predicted to you that there would be less than 9, and with the cell phone right on the sensor, we have in fact detected only 1 change. And there you have it. Before we had 9 changes, now we have only 1 change with the cell phone sitting right on the sensor. And I suggest that's a very profound challenge to our current generation of electrical engineers. Thanks.